Hello viewers. So in this class we are going to take up an important topic in differential equations, that is formulation of differential equations, right? So here uh, we have given the general solution of a differential equation, and we have to formulate the differential equation corresponding to the general solution given. Now let us start with a very simple equation, and we know that the slope intercept form of a straight line is given by y is equal to mx plus c, right? This is the Cartesian equation of a straight line whose slope is m and whose y-intercept is c, right? So here we see that this Cartesian equation contains two constants, right? Two constants, and these two constants are m and c, right? So now let us formulate the differential equation corresponding to this Cartesian equation, right? So what we will do, we'll first take the first derivative of this equation, right? So let us take the first derivative. So dy over dx is equal to m, right? So here the derivative of x is 1, so here we have m times 1, and here the constant is c, which is the y-intercept, and the derivative of a constant is 0, so we have dy over dx is equal to m, right? Now let us again differentiate this equation. Now m is constant, so what we'll have, we'll have d2y over dx2 is equal to 0, because m is a constant and the derivative of a constant is 0, right? So we have obtained this differential equation, right? So the second derivative is equal to 0, right? So the Cartesian equation of a straight line is y is equal to mx plus c, and the differential equation corresponding to this equation is d2y over dx2 is equal to 0, right? Now here there is one important point to note, that the Cartesian equation contains two constants, right? So the order of the differential equation which we have obtained should be 2, right? So we have to differentiate this equation 2 times, right, in order to get the differential equation. So if the Cartesian equation or the general solution of a differential equation contains, say, n constants, right, n constants, then we have to differentiate the given general solution n times, right? So the order of the differential equation should be equal to n. Suppose we have an equation like y is equal to, say, ax square plus bx plus c. Now here we see that we have three arbitrary constants, right? So the number of constants are 3. So we have to differentiate this equation, this Cartesian equation, 3 times, or in other words we can say that the order of the differential equation which will be obtained by eliminating a, b and c will be 3, right? So let us find the differential equation corresponding to this general solution. So here a, b, c are constants, so let us first find the first derivative. So the first derivative is dy over dx is equal to 2ax plus b, right? The derivative of c is 0, and the derivative of x square is 2x, and the derivative of x is 1. Now let us again differentiate this equation. So we have d2y over dx2 is equal to 2a, right? Now again differentiate this equation. So what we will get? We will get d3y over dx3 is equal to 0, because this term 2a is a constant, right? So we have obtained the third derivative is equal to 0, right? So this is the differential equation corresponding to this general solution. So we see that the order of this differential equation is 3, right? And the order of this differential equation is 2, because this differential equation is obtained from this equation, and this equation contains two arbitrary constants, right? So the number of arbitrary constants in the general solution determines the order of the differential equation. Similarly, here we have three arbitrary constants, so the order of the differential equation which will be obtained from this general solution would be 3, right? Now let us take one more example. Suppose we have the family of curves like x square minus y square is equal to a square, where a square or a is a arbitrary constant. So a is an arbitrary constant, so this general solution has only one arbitrary constant. So we have to differentiate this equation only once, right? So let us differentiate this equation. So we'll get 2x minus 2y dy over dx is equal to 0. So if you simplify it, we get 2x is equal to 2y dy over dx. So this 2 and 2 get cancelled, so we have x minus y, or x equal to y times dy over dx. So this is the differential equation corresponding to this family of curves. So here we have only one arbitrary constant, so the order of the differential equation is equal to 1, right? Now let us take the family of curves that is xy is equal to say a square, and here a is an arbitrary constant. So here this is the general solution, we can say, and we have to find the differential equation corresponding to this equation, right? So here we have only one arbitrary constant, so we have to differentiate it only once. So let us differentiate both sides with respect to x. So here we will apply the product rule. So we have x times dy over dx plus y times 1 is equal to 0. So we have x dy over dx is plus y is equal to 0. So this is the differential equation corresponding to this family of curves. So the order is again 1. So always remember, the order of the differential equation corresponding to the general solution is equal to the number of constants or the number of arbitrary constants contained in the general solution. Now let us take this problem. Here we have to form the differential equation corresponding to y equal to e raised to ax, where a is an arbitrary constant. So here we see that the number of constants in this general solution is only 1, right? So the number of constant is 1, which is a. So we have to differentiate this this general solution only once. So differentiating both sides with respect to x, we get dy over dx is equal to e raised to ax times a, right? Because the derivative of x is 1 here, so we have only a. So now for e raised to ax, right? For e raised to ax we can write y, so we can write dy over dx is equal to y times a, right? Now in the differential equation we does not have see here we have a, so we have to eliminate this a from this equation and this equation, right? Now from equation 1, if we take the log of both sides, we get log y is equal to log of e raised to ax, which is equal to log y, that is ax log e, and the value of log e is 1, so we have ax, right? So the value of a is 1 over x log y. Now if we substitute this value of a here, we get the differential equation as y times 1 over x log y, so which can further be written as x dy over dx minus y log y is equal to 0. So this is the differential equation corresponding to this general solution or the family of curves. Here we have only one arbitrary constant, so the order of the differential equation is 1, and moreover the degree of this differential equation is 1, right? Now let us take this problem. Here we have to form the differential equation corresponding to the curve, that is ax square plus by square equal to 1, where a and b are arbitrary constants. So here the differential equation will have the order 2 because here we have two arbitrary constants, right? So we have to differentiate this equation 2 times. So let us differentiate equation 1 with respect to x. So here we'll have 2ax, then we'll have 2b y dy over dx equal to 0, because the derivative of 1 is 0. Dividing throughout by 2, we have ax plus by dy over dx is equal to 0. Say this is equation number 2, right? Now let us again differentiate equation number 2 with respect to x. So what we'll get, we'll have a times 1, then we'll have b, and here y times dy over dx, so we'll have the product rule here, so y times derivative of dy over dx, which is d2y over dx2 plus dy over dx times the derivative of y is dy over dx equal to 0, right? Now we can write it as a plus b times y, and now for the sake of simplicity let us write the notation y2 for the second derivative d2y over dx2 and y1 for dy over dx. So this becomes y2 plus, here we have y1 square, right, equal to 0. So here we have the value of a as a equal to minus b times y2 plus y1 square, right? Now let us write equation 2 as ax plus b y y1, right? Because dy by dx we are taking it as y1, that is equal to 0. Let us call this equation as equation number 4, and now let us eliminate a from equation number 1 and equation number 4. So let us multiply this equation 4 by x, right? So what we will get, we'll have ax square plus by x y1 is equal to 0, right? Now the value of ax square from here can be written as 1 minus by square, and let us substitute this value of ax square as 1 minus by square. So we have 1 minus by square plus byx y1 is equal to 0, right? So this equation can now be written as by square minus by x y1, or we can write b, taking b as common, so we have y square minus xy y1 as 1 equal to b times y square minus xy y1, right? So the value of b is 1 over y square minus xy y1, right? Now let us substitute this value of b in this equation number 3. So the value of a becomes equal to, here we have minus, we have y2 plus y1 square divided by y square minus xy y1, right? So we have now obtained the value of a and value of b in terms of x, y, y1 and y2. Now let us substitute the value of a and b in equation number 1. So now substituting the value of a and b in equation number 1, so we'll have minus y2 plus y1 square divided by y square minus xy y1 times x square plus the value of b is 1 over y square minus xy y1 is equal to 1, right? And here we'll have y square. So this is the value of a, this is the value of a, and this is the value of b, right? So now we'll simplify this expression and we'll have minus y2 plus y1 square x square plus y square divided by y square minus xy y1 is equal to 1, right? Now what we will do, we'll take this term to this side, so we have minus x square y2 multiplying these two terms by x square, so we have minus x square y2 minus x square y1 square plus y square is equal to y square minus xy y1, right? Now y square and y square get cancelled, so taking this term to this side, so we have xy y1 minus x square y2 minus x square y1 square equal to 0, right? Now taking taking x common, so we'll have x y1 minus x y2 minus x y1 square equal to 0. Now here x either we have this term y1 minus x y2 minus x y1 square equal to 0. So this is the required differential equation corresponding to this family of curves.